in so many commercial application or industrial application, it is necessary to measure some physical parameter like light intensity, temperature, humidity, water flow, pressure, and so many other physical parameters is to be measured in some commercial or industrial application. And at the same time, these physical parameters should be controlled. This is a requirement in a industrial application. The instrumentation amplifier measures these physical parameters like temperature, it is humidity, water flow, pressure. The physical parameter like light intensity, temperature, humidity, water flow, pressure is converted into electrical signal. It is converted into electrical signal with the help of transducer. You must be knowing what is a transducer. It's a device which convert the any physical variation into electrical signal. You must be knowing the one example I am giving you. Speaker. Speaker convert the amplified signal, electrical signal, into the sound energy. Or simple example, if when you speak in a microphone, then with the help of microphone, your sound is converted into electrical signal. This is the transducer. This is called the device which converts one form of energy into another form of the energy is known as a transducer. So, you have to see the transducer output. If you see the output of the transducer, it is of the order of few millivolt, or sometimes it is in microvolt. So this millivolt or microvolt signal cannot able to drive the meter, or it cannot able to display in a display indicator. Therefore, it is necessary to amplify such weak signal of the transducer, and from this weak signal you can measure your physical parameter. So we have to amplify this millivolt signal. So for this, operational amplifier is useful. So what is the reason why you are interested to use a operational amplifier? Because it has a high gain with accuracy. With accuracy. Second, the second thing is characteristics does not change with the temperature. Does not change with temperature. Or somewhere it is also written, it is a stability of the gain with stability of the or gain stability of the gain due to low temperature coefficient. Stability of the gain due to low temperature coefficient. Due to this also. Second thing is low offset DC voltage. Low DC offset voltage. Fifth is your CMRR of the op-amp is very large. Sixth thing is a low output impedance. So many things what you can list, but main aim is what this 2 is what good, this 3 is. So due to these reasons, the operational amplifier is used to amplify the output of the transducer. because already just we have discussed the transducer output is of the order of millivolt, so which is not able to drive the meter, and from the transducer output you can get the information about the your physical parameter. So it is required to amplify the output of transducer. So let us first see the basic differential amplifier circuit. Suppose this is your, I am showing you basic differential amplifier circuit. Here's the input voltage to the inverting and non-inverting terminal is V2 and V1 respectively. This is R1, this is R2, this is R3, this is R4, and this is output voltage VO with respect to ground. The output voltage, though any voltage is always with respect to ground, here I am telling you for this circuit. Here you are giving the voltage V1, here you are giving the voltage V1, here you are giving the voltage V2. Let us find the value of the output voltage. So value of the output voltage you can derive, it is nothing but the output due to the input at inverting terminal plus output due to input at non-inverting terminal. So it is nothing but you can say this is your gain multiplied by input at inverting plus gain multiplied by input at non-inverting. So what is the gain? Gain is nothing but the of this, you know, this was the gain for the gain for this is R2 by R1. R2 by R1. So gain is nothing but R2 by R1 multiplied by input. Input you can see here V2 plus what is the gain due to this non-inverting terminal? Already you know that 1 plus R2 by R1 into the voltage at this point. What the voltage at this point? The voltage at this point, let me say V plus. So V plus, you can say it is nothing but the V1 into R4 upon R4 plus R3. So I can write V1 into R4 upon R4 plus R3. So this is minus R2 by R1 into V2 plus, I am taking R2 by R1 common. So here left R1 by R2 plus 1 into V1 upon 1 plus R3 by R4. Again I am writing when I am writing this equation of the output voltage, I am writing here. The equation of output voltage is given by minus R2 by R1 into V2 plus R2 by R1 into bracket R1 by R2 plus 1 into V1 upon 1 plus R3 by R4. If I am taking R1 by R2 is equal to R3 by R4, then you can say this will be cancelled. If you say R1 by R2 is equal to R3 by R4, this will be cancelled. So I can write, look here, I can write equation of VO is minus R2 by R1 into V2 plus R2 by R1 into V1. So I am writing the equation R2 by R1 into, it is your V1 minus V2. So look here, this is cancelled, so you can write R2 by R1 is, you take the common, so V1 minus V2 you can write. See, R2 by R1 is taken, so you will take the V1 minus V2. See, remember, in so many lectures we have discussed that, please, the output voltage is nothing but the proportional to this voltage minus this voltage, means proportional to V non-inverting minus V inverting. So you will get similar type of the equation, V1 minus V2. Now look here, in a circuit, the input impedance seen by this voltage V1, input impedance seen by this V1 is nothing but the R3 plus R4. R3 plus R4. Just to explain you, I am writing here. To explain you, I am writing here. This is 100 kilo ohm. This is 1 kilo ohm. This is 100 kilo ohm. This is your 1 kilo ohm. Then input impedance seen by the V1 is 101 kilo ohm. So, and input impedance seen by V2 is only 1 kilo ohm. Remember, this is very important. Input impedance is seen by the V2 is 1 kilo ohm, and input impedance seen by the V1 is nothing but the R3 plus R4. So, look here. Input impedance, the input impedance seen by V1 is R3 plus R4. Just to explain what we have taken, 100 plus 1, 100 kilo ohm, and input impedance seen by V2 is nothing but the R1 plus R2. So it is R1 only, not R2. It is only 1 kilo ohm. So as a result, this, as a result, you can say, as a result, loading effect takes place. It load very heavily to the source. This is called source from which your voltage is coming, from the transducer. So this load heavily, so you will get input is reduced due to the loading effect. So to avoid the loading effect, we have to use at this stage, we have to use a buffer, or you can say voltage follower circuit. Here we have to use. Listen again. The input impedance seen by the V1 is nothing but the R3 plus R4, and input impedance seen by the V2 is nothing but the R1. So input impedance is here less. So this load your source heavily. So your input is decreases. Therefore, to avoid such problem, the buffer is used before this basic differential amplifier circuit. So see the differential amplifier circuit with buffer that I am drawing you. Look here the way I am drawing the circuit. This is your one buffer circuit I am showing you. Look here, I am keeping the only just for to explain you, I am showing you here the value. This is R, this is the second buffer I am taking here. R dash, and here we have returns. This is nothing but the this is your V1, here I am writing V2, this is output, this I am writing V1 dash here I am writing V2 dash. This is your, due to very high differential input impedance, this voltage drop is tends to 0. Okay, now here's after this is your buffer, this two circuit is buffer, or you can say voltage follower, and this is connected to the your basic differential amplifier circuit. This is your basic differential amplifier circuit. This is a minus, this is your plus, this is your here's this is your output VO. Here I am showing you resistance R1, R2, R1, this is R2. Now we have to discuss on this, everything we have to discuss on this, and we have to derive the equation of output voltage with respect to ground. Say this is op amp 1, say this is op amp 2, say this is op amp 3. So this is your call 3 op amp instrumentation amplifier. Okay, now let us start your working on this. Look here, when this is a buffer stage for this is a buffer stage for this. Here I'll show later on, this is a variable potentiometer. But when V1 and V2 are equal, then these points having a same potential, so current will be 0. So current is through the R and R dash, current through R and R dash will be 0. So here input at this point and input at this point is 0, so output is 0. When V1 and V2 are equal, then this potential and this potential are equal, so current passing through this R is and R dash is 0. As a result, this input is 0, as a result output is 0. Now suppose V1 is not equal to V2, then what will happen? When V1 is equal to V2, then we have written output is 0. When V1 is equal to not V2, then look here, this has some potential difference. Current I will flow like this. This is a direction of current I am showing you. This V2 dash means this, V1 dash is nothing but the same, you can see. So what is the output voltage? So to find the output voltage, we'll use a superposition principles. Look here. So when V1 is equal to not V2, then you will get some output voltage. At that time I have taken this voltage is more than this, so this voltage is more than this voltage, so current will flow like this. That's why I have taken current like this, in this way. Here V1 is not V2, but what is the assumption I am telling you? This voltage is more than this voltage, so this voltage is more than this voltage, so current will flow like this. That's why I have taken current in this way. Now, let us find out the VO. To find the VO, we can write the output due to inverting input plus output due to non-inverting input. VO, it is gain multiplied by input at inverting plus gain multiplied by input at non-inverting. Gain is clear cut, you know, for minus R2 by R1 multiplied by, it is your V2 dash plus 1 plus R2 by R1 into input at V1 dash into R2 upon R1 plus R2. So I can write minus R2 by R1 into V2 dash plus, you take LCM, if you take the LCM, R1 plus R2 will be cancelled with this, so you will get, I think very easy mathematics, so I am not increasing the number of steps, you will get like this. So I can write R2 by R1 I am taking common, so my equation of the output voltage V1 dash minus V2 dash. See, output is nothing but the, what you can write, R2 by R1 into V1 dash minus V2 dash. But I want the output equation in the terms of V1 and V2. I want output equation in terms of V1 V2. So due to this reason, I am putting the value of V1 dash in terms of V1 and V2 dash in terms of V2. So let us put, very easily you can put, look here, from this circuit, from circuit I can write V1 dash is equal to IR dash plus V1, with this is your 0, with this potential and this potential is same, then and then you can say it is 0 voltage. I can write here, it is nothing but the V1. So what is V1 dash? You can say V1 dash is nothing but the, this voltage IR dash plus V1. So I have written. Okay. Now here it is your 0 potential difference, so I should write this V2 is nothing but this is the same. So from this I can write, this is your current will flow like this. V2 is equal to IR dash plus V2 dash. Don't get confused. Yes, voltage, this is higher than this voltage, that's why I have taken V1 dash is equal to IR dash plus V1. You may have question, how can you know V1 dash is higher than this? Current flow like this, slightly higher, don't take so much, slight, so current will flow like this, current is flowing in this direction. So IR dash plus V1. Current flowing in this direction, V2 is equal to IR dash plus V2 dash. So I can write from this, let me put the value in the equation. So V1 dash we have written V1 plus IR dash, and V2 dash we have written, not V2 dash, V dash we have written V2 dash plus IR dash. So V2 dash I can write V2 minus IR dash. So I have to find V2 dash minus V1 dash. V2 dash minus V1 dash. This minus this. This minus this. So this minus this I have to do. I have to find V1 dash minus V2 dash. Sorry, here V1 dash minus V2 dash. So I speak wrong. Yes, I have to find the V1 dash minus V2 dash. So V1 dash minus V2 dash is V1 minus V2 plus 2 IR dash. So remember this, that I have to put this value, I have to put here, this value I have to put here, take care. Okay, so V1 dash I got from the V2 dash, V2 I got from the V2, I have written V2 dash. So from this 2 I am finding V1 dash minus V2 dash. So this value I have to put here. Let me put this value here. So equation of the output voltage R2 by R1 into V1 minus V2 plus 2 IR dash. Look, 2 IR. Now let us find the I. Let us check how you can find I. This current I you can say here, this current I. Clear cut. This voltage minus this voltage, I is equal to V1 minus V2 upon R. You can say clear cut. So from this I can easily write, current I is equal to, the current I is equal to V1 minus V2 upon R. So let me write this in a equation, but current I is nothing but the V1 minus V2 upon R. So if I put this value here, so my equation of the output for a instrumentation amplifier using a 3 operational amplifier will be as follows. So I am writing this value. So from this I am taking V1 minus V2 common. I am taking V1 minus V2 common. I am taking this V1 minus V2 common. Then inside the bracket 1 plus 2R dash by R is left. This is the equation of the output voltage for instrumentation amplifier. Now to explain you, I am taking the value of the R2 and R1. Not necessary it should be like this. Remember, to get some clarity, I am taking let. Suppose R1 is equal to R2 is equal to 25 kilo ohm. Suppose I am writing like this. R is 50 ohm. R dash is your 50 kilo ohm. Suppose I means you see in your circuit. I am showing you in circuit. But this is your R dash. Where is R dash? This is 50 kilo ohm. This is your 50 ohm. I am writing. This is your 50 ohm. This is a 50 kilo ohm. This is with 25 kilo ohm I have taken. 25 kilo ohm. 25 kilo ohm I have taken here. Then what will be my output voltage? Let us check what will be the output voltage. So let us put the value. So equation of output voltage, this is 25k upon 25k, V1 minus V2, this is 1 plus 2 into, this is R dash. I am writing, let me change just to get the easy calculation. I am showing you this is also 25, this is also 25 kilo. Let me say this is also 25 kilo. Otherwise calculation will be lengthy. Here verbally you can do. That's why I have done like this. That's why I change. So here's 25 kilo ohm writing. 25. So now look what will happen. Look the answer. But this is cancel. Now look here. This is 2 into 25. It is 50. 50 upon 50 is cancelled. Kilo means 1000. I think kilo you understand. Kilo means it is called 1000. So this value is 1 plus 1000. And here is only V1 minus V2 is left. This is for just to, otherwise I can take the 50, I do not mind. Then I have to do the calculation here 2 is to be. So this become very easy for you verbally. So that's why I did like so. So what is my output voltage? My output voltage is VO is equal to 1001 into V1 minus V2. Means output is the 1001 times the input from the transducer. It is of the order of millivolt, and this is multiplied by 1001, so you can get very good output voltage. Means this is large value you can get, and this can easily drive the meters. This can easily drive the meters. Okay, so this circuit, look here, this circuit is a work as a instrumentation amplifier which amplify the output of the transducer. But here some problem you have to take care about problem. So what is the problem? Look your problem. Look the equation, you will get the understand. You can understand from the equation. These are to vary the gain. This R can be made variable. This R can be made variable. This R I am making a variable. Look, if you want to vary the gain of the amplifier, you can vary. I am giving this is your 25. So what is my 1 plus 2000? Means 2001 into V1 minus V2. So I want to keep the 10. So by this way you can vary the gain of the amplifier. So look here, let me show the variable circuit. So I am varying, I am changing this. I am giving the potentiometer to change the gain of the amplifier. To change the gain of the amplifier. But by mistake if you are making R is 0, by changing the pot position, if R becomes 0, then look here what will happen. By mistake you are changing the potentiometer to change the gain. If R becomes 0, then this term becomes infinite. So your gain becomes infinite. So to avoid such kind of this, I think you understand. You are changing the gain of the amplifier by changing the R. See in a circuit. In a circuit, you are changing this gain of the circuit by changing the R, by this potentiometer. Okay. But by mistake you are making this R is 0. Then R is 0, then your gain becomes infinite. Your gain becomes infinite. So means the output become constant equal to VCC, like this. So to avoid such kind of the problem, small resistance of a very low, some fixed value of the small resistance is connected in a series with this. This is to avoid this small resistance, small resistor, fixed resistor is connected to avoid the gain become infinite. Such small is connected in series with this. Okay. So this is a complete understanding of your instrumentation amplifier. Now I am showing a transducer bridge circuit which include the transducer, that circuit is shown in figure. So I am showing you transducer bridge. Look here, this is your bridge circuit. Here is a transducer whose resistance vary with the temperature, that mentioned by symbol RT I have written here. This is, let me show resistance R1, R2, R3, and this bridge I am giving you some supply, and some supply I am giving you. Okay, and the output of this bridge is a given to the instrumentation amplifier instrumentation amplifier with 3 op-amp circuit, means that we have discussed. Okay, say there is a V2 and V1, and this output of the instrumentation amplifier is given to the display meter or output device, or it is a display unit. So this is the complete circuit of a instrumentation amplifier. Look here, in this bridge circuit, it is a resistive bridge I am showing you here. The resistance of the one branch is changing with the temperature. Is changing with the temperature, and we want to measure that temperature. That temperature will be displayed here. Okay. So what the way of the circuit is working? When bridge is balanced, when for balanced bridge, V1 is equal to V2, so output is 0. So here output you will get 0. When resistance of this branch is changing with temperature, then bridge will be unbalanced. So it is V1 is not equal to V2. When V1 is not equal to V2, then VO is not 0, or VO, if you use this circuit, then VO is nothing but the 1001 times V1 minus V2, and then output is connected to the display unit, and from the display unit you can measure the temperature of